So in this video, I'd like to talk a little bit about dividing complex numbers. And remember, the complex number was of the form x plus iy. And x was called the real part of z, and y we called the imaginary part of z. So x and y are the real and imaginary parts of z. And this imaginary unit here, I, was defined so that I squared equals minus 1. So that's what I mean by a complex number. I'm now going to talk about dividing complex numbers. So what do I mean by the division of a complex number? Well, you notice here I've got 1 over z. 1 over z is the same as 1 over x plus iy. So what can I do to this to make some sense of this? Well, what I can do is I can multiply by the conjugate. You remember that if you've done any sort of examples where you rationalize the denominator, it's a similar sort of thing here. You multiply by the conjugate of the complex number. Well, the conjugate of this complex number is just x minus iy. You remember in our discussion about conjugates of complex numbers, to find the conjugate of a complex number z, all we do is we take the imaginary part and we flip the sign. So in this case we've got plus iy, that becomes minus iy. So if I take the top and the bottom of this fraction and multiply that by x minus iy, what happens? So I've got this times x minus iy over x minus iy. Remember, if I do something to the bottom, I've also got to do it to the top, so it stays the same. Well, that becomes x minus iy all divided by, well, we've got x squared minus xyi plus xyi. Let's just extend this line. Then we've got minus iy times iy. Well, I squared is minus 1. So I times minus I is just 1. And y times y is y squared. So this becomes positive y squared. So you notice I've got some cancellation here, namely these two terms. So let's do it in a different color. So these two terms here cancel out because we've got a minus xyi and a positive xyi. So when I simplify this, I get x minus iy divided by x squared plus y squared. That's the same thing as x over x squared plus y squared minus y over x squared plus y squared times I. And you notice that in the same way as when I multiplied two complex numbers together, I also got a complex number back. And again, when I took the reciprocal of a complex number, so I divided 1 by a complex number z, I also again ended up with a complex number. And again, this is true. If you divide complex numbers together, you also get another complex number back. So in this case, what I got was x minus iy over x squared plus y squared. By the way, you might notice, you might identify some of these things in this fraction. X minus iy is the conjugate of z. And this thing on the bottom, x squared plus y squared, can be thought of as the length of a complex number, or the magnitude. So x squared plus y squared is actually called the magnitude of z, but we'll get to that to another video when we talk about Argand diagrams and so on. So let's look at some examples. So let's try to divide 1 plus I by 1 minus I. So what's 1 plus I over 1 minus I? Well, we've got to multiply the top and the bottom by the conjugate of this number. So we take 1 plus I over 1 minus I, and you multiply this by the conjugate of 1 minus I. Well, the conjugate of 1 minus I is 1 plus I. So we're going to multiply the top and the bottom by 1 plus I. Well, let's expand the top. On the top we've got 1 times 1, which is 1. 1 times I, which is I times 1, which is I, and I times I, which is minus 1. And at the bottom, we've got 1 minus I times 1 plus I. So the top simplifies just to 2i, because you've got 1 and a minus 1 here, which is 0, and I plus I is 2i, so we've got a 2i left over. Now notice that we've got a difference of two squares here. We've got 1 minus I times 1 plus I. That's exactly the same thing as 1 squared minus I squared, which is 2i divided by, well, 1 squared is just 1. And I squared is minus 1, and minus 1, or multiplying minus 1 by minus 1, is just positive 1. So this is just 2i divided by 2, and if I got 2 divided by 2, that's just 1. So this ends up being I. So 1 plus I divided by 1 minus I is just I. So again, I get a complex number back. Let's look at 1 over I. Well, again, I've got to multiply the top and the bottom of this fraction by the conjugate of this complex number. And the conjugate of this number is minus I. Remember, the conjugate of I is minus I. So multiply the top and the bottom by minus I. What happens when we do that? Well, we get minus I on the top, and at the bottom we've got minus I squared. So that's minus I divided by minus 1, which is just minus I. So this is a handy tip to remember. Remember that 1 over I is the same as minus I. Okay, let's look at another example. What's I over 3 minus 4i? Well, again, we've got I over 3 minus 4i. We've got to multiply the top and the bottom by the conjugate. So the conjugate of 3 minus 4i is 3 plus 4i. So we've got to multiply the top and the bottom by 3 plus 4i. So 3 plus 4i. So this is just I times 3 plus 4i, all divided by 3 minus 4i times 3 plus 4i. And this is the same as 3i plus 4i squared divided by 3 minus 4i times 3 plus 4i. So that's just the same as 3 squared minus 4i all squared by the difference of two squares, which is then the same as 3i. Well, I squared is minus 1, so 4i squared is 4 times minus 1, which is minus 4. And I then divide that by 3 squared minus 4i squared. 3 squared is just 9. And 4i squared, well, 4 squared is 16, I squared is minus 1. So 4i all squared is minus 16. And minus 16 is, of course, 16. So this is just 3i minus 4 over 9 plus 16, which is 25. By the way, you could rewrite this as minus 4 plus 3i if you wanted to keep the a plus bi order. It's not really necessary, but you can do that if you want to. So let's look at this next example. Maybe choose a different color. So let's choose yellow. So we've got 6i plus 8i over 2i. I'm actually not going to multiply the top and the bottom by the conjugate, because you notice that if I then split this up into sort of individual parts, I've got 6i over 2i plus 8i over 2i, which is just 3 plus 4. Because 6 divided by 2 is 3, and I've got an I on the top and the bottom, which I can cancel. Remember, you can cancel imaginary numbers just as you would do with real numbers. And likewise, I can cancel an I on the top and the bottom here. So I've got 6 divided by 2, which is 3, times I divided by I, which is just 1. So I've got 3 plus 4, which is 7. So that's that example. I've now got to find 3 plus 5i divided by 7. Well, this is just the same as 3 over 7 plus 5i over 7, which is 3/7 plus 5/7